Hello everyone, my name is Scott Bates. I'm going to be going over LTF running the stairs lab activity for the Physical Science Year 1 training. So this lab activity is located in Unit 6. It deals with energy, mainly dealing with power and work, and it does relate to potential energy. This is I will say this is one of the more difficult labs for students to complete. There's a lot of math and equation manipulation in this activity. I do have to walk my students through certain parts. This depends on the class. Some classes can, they just need a little help, but some definitely need a lot of help with this lab. So, for you to get full credit for this activity for the training, you need to make sure you complete and follow the directions for this activity. And also, there's a post lab discussion in Canvas. There's two questions you're going to be asked: how would you incorporate this lab in your school, and how would you plan this lab in your school if you did not have access to stairs? Now, I know that we are in a COVID-19 world, but just try to think about like how would you do this in 2020 because that's what's coming up. So I know that it may be more digital. I would love to hear your ideas on how you would do this. I've seen a lot of different teachers do it various ways and break it up because of just not having stairs and stuff like that. So the main objectives are to determine the work done against gravity while running up a flight of stairs and to determine the power level at which which they perform the work. The Marzano strategies, you got processing content, structured practice sessions, maintaining a lively pace, asking in-depth questions of reluctant learners. So this is a very, very fun lab. Even though it is really math heavy, you do have some movement because you are literally going to be running these stairs. So anyway, let's get started. So there's some information about power and work, and there are the formulas right here. I will say that, and this is probably kind of hard for the students to grasp, is they need to know that work and energy are measured in joules, and power is measured in watts. And units are extremely important in here. And this is actually with this lab, I'm actually able to analyze and see where my students are actually making mistakes because of how I ask to receive the work. Now, normally for this lab, you would actually get the students to weigh themselves in pounds, and then they would run up some stairs and you would time them, and you would have to measure the height of the stairs. Now, measuring the height of the stairs, I always let my students work through that. How would you measure the height of the stairs? I always ask them, and they would come up with random things, take some meter sticks together, the answers, and some would, but the best ways to do it would either be, and I've let classes do it. It's up to them how they want to do it because I tell them, it's accuracy depends on them to measure each individual step and add it all together. Or they could use, if you have a long tape measure, you can do that. Or you could actually use string and measure the string. I've had different methods. I let my students decide. So obviously during this time, we would do this lab and we would do all this, but we don't have access to that. So I actually weighed myself, ran up some stairs, or went at a pretty good pace, and I timed myself, and I got my height right, or got the height of the stairs as well. So if you do not have if you don't want to weigh yourself, you don't have access to stairs, especially if you do not have access to stairs, then use these values right here. Now, if you can't just change the weight here. Technically, if you change the weight, you find it for you. But the thing is, like, you may go a different rate than I would. So just think about all that. But just use these values if you don't. Now, if you have access to stairs, you want to measure and actually do it yourself, then go for it. So again, this is just the instructions on how to do this lab, everything I just said. Right here, data and observation. So everything here is graded. So right here, height of stairs, you would put that 3.1 value if you don't have stairs at your house and not using your own. The time to climb stairs, same thing. Use that 25.14 seconds right here. Now this is where the formulas start coming in. Now this is where the calculations can get kind of hairy. Now you do need to make sure you insert the image of your math calculations at certain points. And I'm asking for that, not to make sure you do it, but it's another way is think about what you want to see from your students when they turn in work. You know, And when I'm looking for calculations, I'm looking for the formula that you use and, the values put in for each variable. And I'll just show you an example. But before we do get started, and this is something the students really do struggle with, and that is the conversion from pounds to kilograms, because you got to get that mass. So when you're converting, and again, if you're struggling with converting Kentucky Island, Rachel Haley did a really good video on that. That's a really good lab about converting. You can refer back to that. But if you have 220 pounds and you multiply, the conversion is 2.2 pounds per 1 kilogram. So we're going to put pounds on bottom, 1 kilogram on top. You can multiply that together and you're going to get your mass. Now, this is going to be, I think it's like 100 kilograms or something like that. It just worked out that way. I thought that was kind of unique. I guess I'm a good weight right now. But you're going to use this, and that is something students need to realize. They're going to use kilograms, not the metric system for pounds. Now, when you get to the next section, you have to calculate the work. How much work did I do, or did that student do? And so when you're thinking about that, we're going to use that formula work, and this is what I'm looking for in the calculations. So I'm going to put the formula that I'm using: work equals mgh, mass, gravity, height. Now, for my students, I actually want them to plug in the values here, because I do that, and I actually want to see that as well for y'all. And the reason that is, if they just put mgh and they multiply it together and they get an answer and they put the thing, I want to see to make sure they actually have all the correct values. And again, I'd put 100 for the mass if that's correct. Again, you might want to double check me. 100 kilograms, the gravity 9.8 meters per second squared, and then that height, which is 3.1 meters. And then, of course, they would use the calculator and they'd put that answer, and they'd make sure to put that answer in joules. And now, I'll be honest, some of these, it depends on, how high, how much the mass and all that stuff. You may get very large numbers. And so it may be a great time to make sure they use significant digits and they use correct scientific notation. So if they got like 5,768 joules, you might want to say, okay, that's going to be 5.7 times 10 to the third, or whatever it is. And again, it's just however you want to do it, but you need to make sure that they actually do use joules in their units. But right here, like I said, I can actually see, and if their value isn't what it's supposed to be, I can look and see which values they used. If it's all correct, then they just typed in the calculator wrong. If this number right here is a different number, I know they messed up right there. It's a great way to do it. So think about that when you're inserting your calculations. I do want to see the formula, and I want to see that, like I said, the plug-in of the variables. So for number 2, kind of the same thing. You're going to be calculating power. Again, the power formula is right here: work divided by time. So it does build upon itself. You're going to use the answer from the previous problem to get that one. That one's not too bad. And again, make sure you put the correct units for that, and you get your students to its watts. So now the conclusion questions is where this lab really shine, because these questions can be difficult, but it's all about equation manipulation. You're getting your same equations, but you're actually just affecting the values, and you can actually work through it, and they can actually see, okay, if you did half the time. So again, like for number 2, for instance, how would the work done against gravity change if you ran up the stairs in half the time? Well, you could actually get your students to show it. I mean, I'm not asking for required calculations here, but they could, okay, half the time, and then they could calculate it, and they could actually see, oh, that was what would happen if we ran up, in half the time, or twice the time, twice the value, and again, work it out. And again, they're justifying their answer here. And this is a very good verbiage right here too, because in the ACAP, there's a lot of justifying. Power level, again, it's the same thing. All they have to do is go to those values and actually do it. And when they get to this section, they're like, oh, I don't know how to do it. And I'm like, well, you know what time is? I mean, you just got to break it down. And once they do it, they're starting to realize they can do some of these harder questions. Now, when you get here, you talk about Brutus, you can actually pull up bring up another person if you would like, bring up an actual student example. That's perfectly fine. And it talks about calculating the potential energy right here. Now, potential energy is very similar to the work formula. Again, this is something that they will slowly start realizing in a way. And you can you can actually relate, potential energy with height, if closer to the ground, more potential energy and so on. And right here, a kilocalorie for number 5. So this one actually can be a tough one. So they don't realize that a calorie is actually a kilocalorie. We just call it calories, but it's actually a kilocalorie. And so the thing is, they need to realize like how many calories that we burn when we do things and stuff like that. So that is the conversion, which does throw them off. So you may have to remind them, you know. So they have their answer in joules from the first part, and then they're going to have to convert to calories here. And so I actually written it down myself, the conversion. So you got that 4,184 joules, because this is your answer is going to be in joules from the first part. This is the second. This is the conversion. So then you got 1 kilocalorie here, and you would equal it, and your answer would be in kilocalories. And again, I would recommend significant digits here. 2 or 3. It's supposed to be 2, I believe, but if you're trying to mess with rounding with the students and stuff like that, it's also a good way to mention that as well, because you don't want a huge decimal. And then right here for letter B, this always throws them off too. And again, this section I almost have to walk through them just a little bit with my students, because it is kind of hard for them to understand. And so right here, if you ate 50 kilocalories of cheese curls, what percentage did you actually burn? And so think about, it's going to be the answer from A. Think about, okay, that's going to be on top over the total, which is 50 kilocalories. And then don't forget to multiply by 100 just to get that at a percentage. And then lastly, C, you have to, assuming that all energy of cheese curls could be used by the human body, how high would you have to climb to burn all of that? So, and a good way to think about it is, just think about it, it's the same formula. It is the same formula. So just think about it. So you have 50 kilocalories, which equals, and again, this right here, just think about it as, so you converted joules to calories. So consider this the work formula. So you got work equals mgh. Well, you have m, you have g. What you're looking for is your how high. And again, what I like to do is this right here. I will tell the students, okay, what are you looking for? They're looking for how high would I have to look for? Well, the thing is, okay, what formula has height in it? They eventually find that, okay, work equals mass gravity height. Height is right here. So well, do we have the other things? So that's how I break it down to where they get to there. So they do have to get there. Now, some classes I have to help more than others, but if you tell them, if they figure out what they're looking for and they look at the formulas, that a lot of them can figure it out. And again, this right here is a lot of error that can be described. There's a lot of different answers for that. But that is it for that lab. Hopefully this will not be too awful bad. Make sure to include your calculations especially for like this one right here. For A, B, and C, make sure you put all your calculations for this. You can put it in one document if you want to, one picture, or you can put separate pictures. It's up to you, whatever's easiest for you. But watch out for calculations here. And again, after this lab, go to the post-lab discussion. How would you do this lab in 2020, 21 year? And how would you, if you did not have access to stairs, how would you do it? Because I want some ideas, because there's a lot of teachers that don't have access to stairs and they have no idea how they would do it. And so it's nice to have someone that may have an idea how to do that. Anyway, well, hopefully that helped. Good luck.